Homo Universalis video number 1. Mathematics Calculus Part 1. Interesting derivations of antiderivatives. Huge thanks to the channel Professor Dave Explains for inspiring this video. We know 3 integration methods which work for a wide variety of functions, from rational and polynomial to composite and trigonometric. These include the trigonometric and u-substitutions, integration by parts, and partial fraction decomposition. We can use these results to evaluate definite integrals through the fundamental theorem of calculus. Let's integrate the product of 2 trigonometric functions by using the u-substitution. Here we have the antiderivative of sine x times cosine of x. We will allow u to be equal to the sine of x. Then du will be equal to the derivative of sine x times dx. The derivative of sine x is the cosine of x, so du will be equal to the cosine of x times dx. We now have the antiderivative of u with respect to u, where u is equal to the sine of x, and du is equal to the cosine of x times dx. There are several things to note about this integral. First, the integrand is now a simple monomial. Moreover, the integrand is not a product of 2 functions. Finally, we can use simple integral identities to solve this antiderivative. Remember the rule for taking the antiderivative of a monomial of degree n. Its antiderivative is equal to its degree n plus 1 divided by n plus 1. From this, we derive that the antiderivative of u with respect to u is 1/2 of u squared plus the arbitrary constant. Now we substitute for u is equal to the sine of x to derive that the antiderivative of sine x times cosine x is 1/2 of sine squared x plus c. Now let's solve the same integral by using integration by parts. We will allow u to be equal to the sine of x and dv to the cosine of x times dx. In order to derive the unknown differential du, we need to differentiate sine of x. While to derive v, we must integrate dv. If u is equal to the sine of x, then du is equal to the derivative of the sine of x times dx. The derivative of the sine is the cosine, so du is equal to the cosine of x times dx. If dv is equal to the cosine of x times dx, then v is the antiderivative of the cosine of x times dx. The antiderivative of the cosine x is sine x, so v is equal to the sine x. Now, by using the rule that the antiderivative of u dv is equal to uv minus the antiderivative of v du, we derive that the antiderivative of sine x times cosine x is equal to sine squared x minus the antiderivative of the sine x times cosine x. We now derive that the integrand of v du is the same as that of u dv. This integral will repeat infinitely. However, we can still find a multitude of ways to evaluate it. One way is to use further substitution. We will let I be equal to the antiderivative of sine x times cosine x. From this, we derive the equation I equals the sine squared x minus I. By adding I on both sides of the equation, we get that 2i equals to sine squared x. Finally, after dividing both sides of the equation by 2, we get the result 1/2 of sine squared x plus c. This result is the same as we derived by using the u-Substitution. Another more difficult way is to use an infinite series. Again, we will let I be equal to the antiderivative of sine x times cosine x, which results in I equals sine squared x minus I. We will substitute for I on the right side of the equation to get I equals the sine squared x minus the sine squared x plus I. We will then repeat this process an infinite number of times to derive that I equals the sine squared x minus the sine squared x plus the sine squared x, and so on, plus c. We can generalize the series as the sum of -1 to the power of n times the sine squared x as n goes from 0 to infinity. We notice something peculiar in our series, as the -1 to the power of n clearly resembles Grandi's series, which alternates between 1 and -1 an infinite number of times. Grandi's series mathematically converges to 1/2, from which we can derive that the solution to our series is 1/2 of sine squared x plus c. This gives us the exact same result as we derived 2 methods prior. This is extraordinary because it proves the solution to Grandi's series correct. By all means, we have derived the final result, that the antiderivative of the sine of x times the cosine of x is equal to 1/2 of the sine squared x plus c. This product of two trigonometric functions could be evaluated in 2 ways. First, we used the u-Substitution, which luckily gave us the exact answer after the first attempt. However, when we used integration by parts, we found 2 ways of evaluating this integral. First, we used an algebraic equation. Second, we used an infinite series in order to derive the answer. This will not always be the case. Integration by parts often works by the second attempt. Thanks for watching. Subscribe to the channel Homo Universalis and like this video. Our next video will be Sicilia, Rome's first province, part of a large series I will be making on all Roman provinces. Fiat lux.